Okay, today's video we're going to talk about direct variation, and this is very similar to what we've been doing with slope-intercept form, okay? So direct variation, this equation is y equals kx, and we know that this is very similar to y equals mx plus b, right? So we will learn that in direct variation, this k is your slope, okay? It's a number that relates your y and your x, and your b is 0. So that means that we are starting at the origin every time we graph, okay? So what we know about this is, let's add one more thing, that k is called the constant of variation. Okay, and you may be thinking, why are we learning about this again? Like, why do we have to have so many different ways to see this? Again, it's just kind of how it is, okay? So you may see problems on the PSAT or on the SAT where it's talking about direct variation, or you're seeing an equation that looks something like this, okay? And so it's always good to just know more than one ways of how things are represented, okay? But I want us to be able to think back to the equation we've already been learning and notice how it's almost the same, okay? And so what we're going to fill in here is it always goes through the origin. So I've already said that because our b becomes 0, okay? So we're always going through the origin. So if I want to graph this type of equation, again, we've already done something like this before. We've pretty much already graphed this. So this number in front of the x is your slope. It's how you are moving, okay? And so I'm always going to start at 0 on every single one of these graphs, okay? We don't have a y-intercept. This is why it's a direct variation equation. So now I'm going to use this number 2/3. We're going to go up 2 over 3 right here. And so remember, slope is rise over run. And then I can connect those points. Okay, this one we have y equals -2 over x, so I'm going to turn this into a slope of -2 over 1. So we're going down 2 over 1, down 2 over 1, and I can connect. Okay, and then the last one here, I have y equals -3/4 x, so I'm going to go down 3 over 4, so right here. Okay, so I'm going to put up some examples, and you're going to have to select the right graph that represents the equation. Okay, so take a minute or so to kind of do that, and hopefully you'll do okay. Okay, so we've been talking about word problems. Okay, this one isn't really a word problem. We just have to set up the equation. The next one is going to be more of a word problem, okay? So this first one here, it says the y value is 3 times the value of x, okay? So we always want to say y equals, right? We're saying y is -3 times the value of x. So I'm going to write -3x. So direct variation, again, is just comparing your x and your y, and there's always something that is happening to your x that causes your y. So we can say, all right, my x is just -3 times, and that's how I get to my y. Okay, that's the direct variation. That's the relationship between the two. So let's make a table. Again, I just like picking -2, -1, 0, 1, 2. So anytime you're asked to make a table, these are kind of the go-to numbers, okay? So making that table, I'm going to plug in -2 for my x, right? Like if I want to graph this, let's just kind of fill this in here. And -2 times -3 is, hold on. I feel like this key that I'm looking at is backwards. And it definitely is. Okay. I'm going to have to cut that out. Okay, so what we're going to do is just fill in this table. So we have -2 plugging in for x here. So -2 times -3 is 6. Then I have -1 times -3, which is +3. 0 times -3, which is 0. 1 times -3, which is -3, and so on. Okay, so we could have also just graphed this like normal, right? If I want to graph this, my slope is -3/1, so I'm going down 3/1, and that will make my line. Okay, here it says the total cost C of gummy bears is $2.50 times the number of pounds P. Okay, so it says my total cost C of gummy bears. So I like to think of my Y as kind of like the total cost, okay? So we haven't dealt with a type of problem like this yet, but in the form y equals mx plus b, or we're talking about a specific version of this, our direct variation y equals kx, again, where m is k, we're just kind of switching out the variable here, we're going to set this up as c equals, and it wants us to use this variable instead of our x, okay? So it says the total cost C is our $2.50 times the pounds P. Okay, so I'm going to write 250p. That's how I can find my total cost. All right, so we can graph this, and then let's also represent it as a table. Okay, so let's go ahead and kind of graph it first, and then let's see how our table kind of goes. So my slope is 250/1. So I'm going to go up 2.5, right? So I'm just going to go and make my point right here, up 2.5. Now here's kind of the tricky part, right? We want to go up 1, so you're going to still have to go up halfway, go up another halfway, then go up like that. So we're now at 5. Okay, so same thing, go up 2.5/1. Again, I just want to point out that all of our lines start at 0. So when I'm making my points, this graph does not have all 4 quadrants because we can't have negative pounds of gummy bears, right? That wouldn't make sense. So all of our numbers are going to be positive. So instead of choosing like -2, -1, 0, 1, 2, I'm just going to do 0, 1, 2, 3, 4. I want all my numbers to be positive, okay? So then plugging in P here, 0 times anything is 0, then 1 times 250 is just 250, 2 times 250 is 5, 3 times 250 is 750, and 4 times 250 is 10. So pretty easy stuff. I'm probably boring you right now, but you know, we just have to know that direct variation exists. Okay, then on the back side, here is a type of problem that you will probably see the most often. And you'll probably be, I want to find a problem like this on the PSAT to give you guys. So you'll see a really weird statement like this that says, suppose y varies directly as x. And you're like, what the heck does that even mean? That is our direct variation. So this should automatically be giving you warning bells. Okay, I need to use y equals kx. Okay, so it's going to tell me if y equals 9 when x is -3, I want to find x when y is 15. So there's a lot going on here. First, we're going to look at the first half of this. It says if y equals 9 when x equals -3. I'm going to set that up. I'm going to fill in to my equation, right? We're using the direct variation equation. I'm going to fill in y as 9 and x as -3. Okay? So what this is I want to figure out what do I have to multiply x by to get to the 9, right? Like what do I need to put in for this k here? What am I multiplying every single thing by? Okay? So we can figure that out by dividing by -3, right? And we can find that k is equal to -3. So if I want to find x when y is 15, I now have that k value, and I can kind of go in reverse, okay? So if using, again, the same formula, y equals kx, I'm going to plug in 15 for y. I now know that k is -3. This can help me find x. So I'm going to divide by -3 on both sides. That gives me x is -5. Okay? So again, this is just the first step that you're always going to do is find k. That's the first thing that you need. You need to find what that direct variation number is. Then you can go back and plug that in to help you answer the question. Okay? So let's try this again. I want to find k for this example. So I'm going to rewrite this equation here. It tells me y is 15. I need to find k when x is 12. Okay? So now, if I want to find k, I want to divide by the 12. So I have 15 over 12. I can reduce this, or if you want to put it as a decimal, that's fine. So typing it in, it should give you 1.25. Okay, so now, going back to the question, it says find y when x is 32. So using this formula, we're going to say y is equal to, I know my k is 1.25. My x is 32. So I'm going to multiply those two together. That gives me y is 40. So again, it's giving you a statement, and it's saying, what is the relationship between those numbers? Like, how do I go from x to 15? Well, I found out that that k, that variation number, that means I'm multiplying it by 1.25. So that's the relationship that's happening between y and x. So then that helps me answer the second question, okay? So we're going to try one more. I'm going to have you do the last one on your own, and then I'll have you try a couple more after that. So we have y equals -11 when x equals 6. Actually, I'm going to have you select the right formula for this one first. Okay, so hopefully you chose -11 equals k times 6. Okay? Hopefully that was the one that you chose. So now I want to divide by 6 on both sides. So when I do that, I get -11 over, the key doesn't have it as a decimal. So, and I don't have my calculator nearby. So I'm just going to write that for now. And then we'll see what it is as an actual decimal. Maybe it is, yeah, it's a repeating. So yeah, so here's the thing. If you get a repeating decimal like this one, it's 1.8333 repeating, I would just leave it as a fraction, because if you're even rounding slightly on this, it's not going to give you an exact answer. So let's just keep it as a fraction. And so now when I set up my problem here, I want to find x when y is 3. So I'm going to replace y with 3. K is that -11 over 6, x. Okay, hopefully we can remember, if I want to get rid of a fraction in front of my x, I can multiply by the reciprocal, right? So I'm going to multiply by -6 over 11 over here, typing that in, and this cancels out over here. Typing that in, I get -18 over 11. Okay, so I'm going to have you completely try the last one on your own. We'll see how it goes. Okay, hopefully your equation looked like this. 0.5 equals k times 4 by replacing the x and y. Then you should divide by 4 to help you find k. So your k is 0.125. Now we can plug that in and actually answer the question here. So we want to find y when x is -3. So I know my k, replacing that here, tells me x is -3. So I'm multiplying those two. So that gives me an answer of -0.375. All right. Hopefully this isn't too bad. It's just kind of a weird question, but it will come up. So try a couple on your own, and that's it for today. If you have any questions or anything, you can always email me. But other than that, I hope you guys have a wonderful weekend.